Hello everyone, welcome to a new lesson on Laplace transformation. We will not go into too much details of what Laplace transformation is, what is the importance of it, where do we use it, etc. Rather today we will focus more on how to prove the fundamental formulas of Laplace transformation that we are going to need in future. So without further delay, let's move into the lesson. In this lesson we will see how to derive the Laplace transformation of some elementary functions such as e to the power t, sine of t, cosine of t and so on. Before moving on, let's see the definition of Laplace transformation and its expression. Suppose you have an well-defined function f of variable t which is time and another constant parameter s, then Laplace of f is defined as this equation. Laplace of f of t is equals to integration from 0 to infinity e to the power minus st times f of t dt. Now let's start our proof using the expression. Our first formula is Laplace of e to the power at or minus it. Now recall the expression we learnt before and try to apply it here. So we put e to the power at here instead of f of t. Now we can write this part as this. Now taking minus t out of the brackets we get an expression similar to this. After that, we need to use this integration formula and we will get to this part. After putting the higher and lower limits to the variable and simplifying a little, we will get to our desired solution. That's how we find the Laplace of e to the power at is 1 by s minus a. In a similar manner we can also show that Laplace of e to the power minus it is 1 by s plus a. You can try it for yourself. Now let's move on to the next formula. Laplace of sine at and Laplace of cosine at. To prove, we need a special expression known as Euler's equation. The relation is as follows. Using the two equations we can rewrite sine and cosine in this manner. Now with the help of the form of cosine let's take Laplace of it. Here you need to remember two important properties, that is Laplace of addition of two functions is same as taking Laplace of each function separately and add them together. And Laplace of a function multiplied with a constant is equal to Laplace of the function multiplied with that constant. So our expression can be written like this. After taking out 1 by 2 out of the Laplace, we see a familiar function whose Laplace is known. It's the formula 1, e to the power at and e to the power minus at. Using formula 1 and doing some simplification we will get our required solution. Laplace of cos at equals s over s square plus a square. Similarly, we can deduce the formula of sine at. Now let's move on to the next formula. Laplace of t to the power n. Now there are many ways to prove the formula. The easiest way is to use the gamma function. We will not go into much detail about what the gamma function is and where it comes from, we will only see what we need here right now. So the expression of the gamma function is gamma of n plus 1 is equal to integration from 0 to infinity x to the power n into e to the power minus x dx. We will be using this part to compare our expression and this formula. You must remember that the gamma of n plus 1 is n factorial. This is must to remember. Now we start by putting t to the power n in the expression we learned in the description. Let's consider s times t is equal to z. By taking the derivative on both sides we get s dt equal to dz. Next, we get the value of dt. After we put these expressions in our main equation we get something similar to this. As we take the s to the power n out we will recognize the remaining part to be the expression for the gamma function. Thus our expression becomes this. Or we can write it to be this. So finally we find the Laplace transformation of t to the power n. There are two very important relations we need to learn. Laplace of t and Laplace of 1. When we put n equals 1 and 0 in the above formula, we find Laplace of t is 1 over s square and Laplace of 1 is 1 over s. Congratulations! We have learned the derivation of the most important Laplace transformations that you need in every step. Now let's revise the formula from the above table. If you learn this table you can solve most of the Laplace transformation you would need. Thank you all for watching. If you like the video, let me know in the comments. If you want to see more videos like this, subscribe to the channel and click the bell icon next to it.